Hi, I'm Claire from Greenroads. We started this venture because we knew that there was lots of traffic, problems with pollution, clutter with too much cars on the road, and roads not being targeted towards being environmentally friendly. And on starting this, we realized that actually one of the core problems was the data that's being collected currently. It's using information based around cars. So if you are taking into consideration only statistics related to cars, then by consequence, you're designing roads which are more adequate for cars as opposed to pedestrians and cyclists. And the way that we're tackling this is by being a data-driven startup. So we consulted with a lot of entities and urban planners, and we realized that one of the best ways is to provide information about what's happening on the roads. And basically, we created the software which looks at the different modes, movements, understands whether it's a pedestrian, whether it's a vehicle, where they are going, how they are moving on the road, and basically takes into consideration the trajectories as well as the speed. And that's all recorded in a GDPR compliant manner and then presented, such as the chart over here. This shows basically pedestrian trajectories of how people are moving and how they are crossing the road. And consequently, the bus stops were adjusted and the pedestrian crossing addressed more the needs of pedestrians in that area. And cyclists were given a more cycle lane, and the other pavement was optimized for pedestrians. This is fueled by the need for cities to transform themselves into smart cities of the future that actually address the different moves in cities. Now, from here, I hand over to my colleague, Johan, who will show you a demo of how our software works and what a client can expect to see from the interface point of view.
Claire, you need to stop sharing. I can.
Okay. Stop sharing.
Okay, share screen. All right, good afternoon, everyone. I think you can see my screen. It's Johan, I'm the CTO at Greenroads, and for the next 2 minutes, I'm going to actually show you a live demo of what Claire has been explaining to you. I just logged into our system, and the system shows you, can show you a map of where your cameras are. Then you can just click on a map. I'm just clicking on the list of the maps. You see that cameras are live, and you click on a map, and it will give you. Let me choose a date of yesterday, for example. So as you see, we've already built the whole system. At the moment, we are focusing more on commercializing and scaling up, but the system is ready and fully ready to go. As Claire was explaining, there are 3 major features of the system. The first one is obviously the most obvious: counts of vehicles, of bicycles and pedestrians. There is also turning ratio. So if an urban planner, for example, is studying this scene here of a valley in Malta, a side street of a valley, if the user clicks, you can see that 97% kept on going, 3% are changing route to the right. There is also graphs, so graphs of number of vehicles, graphs of speed, and obviously there is always a breakdown of what is happening. The peak hour in the afternoon, between 7 and 8, the peak hour in the evening between 5 and 6, obviously related to the rush hour going to work and coming back, and the number of vehicles. The second important feature would be the trajectories. A big focus is on especially the pedestrian trajectories, as Claire was saying. So with any camera that is connected to the system, the user, being an urban planner or someone working in road management, can see where this is live data. Actually, it's from yesterday because I changed the date of yesterday of where people were walking on the street. Of course, you see that they were walking obviously on the pavement. Sometimes they come crossing the street from here, and you see on the other side as well. So that's the second feature, major feature. Then there are obviously a whole lot of reports. I'm just going to show you like one hourly report with the average speed and the number of cars that there were. Then the third thing would be events. So let's assume, for example, that we wanted to analyze, and I'm going to show you how many people, how many cars are parking in this area. So we just can add a zone, give it a name, just rotate and do the zone that you want to sort of see in terms of parking. Let's not waste time. Let's put it like this, next, and finish. And the system actually starts from there on calculating the number of events that are, I can show you, the number of parkings that are in those boxes. Of course, from all this data, the urban planners can take informed decisions on the data that they gathered. The system has a lot of more features. I'm going to stop here. It can work both through live cameras, so a user can add his own camera, and also work in terms of files. They can upload their own snippet, and the system can process the contents of the file. I'll stop here, then we'll evolve in the Q&A.
Very good. Thank you very much. Okay, Tiana, first question to you, my friend.
Sure. Thank you, Johan, for the product demo, and so nice to see you again, Claire, going strong. I have two questions. One is regarding what we discussed last time about kind of niching down and focusing on certain type of customers. And I remember you mentioned that would be the city executives, leadership of the cities. Is that still the plan? And have you maybe developed some specific features in the meantime to target this type of users and customers? And the second question, as Johan mentioned, the product is already kind of advanced, ready to launch, right? During this course of development, have you taken some turns based on some feedback? Maybe you can share these details with us as well. Thank you.
Yes, in fact, we started this project development based on the needs of the local infrastructure entity, and we spoke with them, we understood their needs, and we addressed them by coming up with this platform. In addition, we also were speaking to the enforcement entities and the local councils, and we realized that they had questions around where were illegalities happening at what time, so that they could then in turn send enforcement on spot to monitor that particular area, or so that instead of checking videos manually, they could actually check spot on where the infringement or where the anomaly or where the event has occurred. And that's why we developed the second feature that Johan showed you, where the boxes were structured and placed.
Yeah, so that was new. Great, thanks.
Welcome.
Pedro, over to you.
Thank you. A couple of questions also. One is, have you considered addressing public transportation companies? So help them design routes across the towns. And the second one is, I guess the cameras are not owned by you, so you are using third-party cameras. It's like a partnership, it's like a supplier. How do you deal with them?
Generally, the cameras are owned by the cities themselves, so they already have this infrastructure in place, or the local councils or the municipalities. They're tracking these or recording these manually, or they're not leveraging them at all. And we take the RSTP link. It's a very simple protocol of how the video would communicate with our system, and in turn the processing happens. Your previous question was around
public transport.
Yes, so the information is more targeted towards infrastructure entities and more towards urban planning, but we are also talking to public transport companies, in fact, in Spain, because they want to understand how pedestrians are using areas surrounding the bus stops, so that then in turn they could make them safer, they could address more peak hours and maybe increase the supply of public transport if there are too many people waiting at a particular time, so on and so forth. So that's the use case in terms of urban planners and versus public bus stops. Could be also used by services. So for example, if there's a station where people stop to pick up a parcel or to refuel or things like that, you could as well know the optimization of drop-on and pick-offs of certain areas.
Okay, thank you very much, Matt. The honor of the last question on this one, and then we'll go to Henrique for Wildbrand. Okay.
Cool. So yeah, great pitch. I was going to ask about the tech that you're using for the object recognition. Is that kind of an open source framework you're using, or kind of proprietary?
Yes. So we use we have our own proprietary software which we've built. In doing so, but we've used YOLO, which is a commonly open library for computer vision. So we started from YOLO, but then we have trackers, we have detectors, which we sort of joined all together, and then it became our proprietary software using some open source in the meantime.
Great. And one more question: is it possible to train to a degree where you can identify it's a pedestrian, but maybe it's a pedestrian with disabilities or someone in a wheelchair? So I think about in terms of kind of making places more accessible, that kind of information.
Yes. So as initially the MVP was very focused on identifying all the kinds of vehicles and pedestrians. From there, we are evolving. So, for example, e-scooters, before they were not popular, so we had to insert those. Even trying to identify whether it's an electric vehicle or an actual a fossil fuel based. So we're getting into all these. And this, what you just said in terms of people with disability, yes, you could train the system. At the moment, we don't cater for that, but we do have plans of sort of identifying sort of the edge cases. So now that the system is built, it's learned, we have with a good camera, we can arrive to 98-99% accuracy. But then the edge cases, if a person, for example, on a wheelchair, what does it determine? So you can focus the training. You get new data sets, and you train the system for these edge cases, so that the system not only performs in things that has already seen a million times, but also these new types, it can identify them as well.
Brilliant. Thank you.
Okay, fantastic. Thank you very much, everybody.